Wearables have always been this cool niche of electronics. People have always been building electronic projects meant to be worn by the user, and over the years we've seen a lot of nice ideas of watches and other types of bracelets, but there's always been the issue of the enclosure and form factor. Most of these projects were only some stacked PCBs with no enclosure, and those that had an enclosure were usually not easy to build with common tools. The 3D printing revolution kind of solved that, but not entirely, because 3D printing at that lower scale is difficult and results are often not waterproof or dust proof. And here comes this gadget I want to show you today. This is a smart bracelet. It's called a T-Wristband, and it's from LILYGO. And I somehow feel like this is the result of the smart bracelet boom we've had in the past years, which pushed the industry forward, and you can now get something like this manufactured for cheap. This is based on the ESP32 Pico D4, so it has built-in Wi-Fi and Bluetooth. Because of that, it's got an IPS 0.96-inch screen, an RTC for keeping the clock accurate. It's the PCF 8563. It's got a touch button for user input with a special defined area molded in the case, and this is handled by a dedicated touch IC, which is the TTP223. It also has an inertial measurement unit, the MPU 9250, which combines an accelerometer, gyro and magnetometer. We have a built-in 80 mAh LiPo battery and a TP4054 charger. There is also a window for a heart rate sensor on the back, but there isn't one fitted on the board. So the specs are not bad at all considering the hardware. There is a bunch of projects you could build on this hardware. And if this hardware is not enough, you can just use it as a reference and build your own boards to go inside the watch. I recommend you check out PCBWay.com, a professional PCB manufacturer with quick turnaround times. Here is an example PCB which I ordered for an upcoming project. It has matte green solder mask and INI gold finish. Doesn't this look nice? We'll also take a closer look at the hardware a bit later in a teardown to see if it matches these specs, because I've seen some conflicting specs on different sources on some of the aspects like the IMU sensor they're using or the capacity of the battery. Hopefully that is marked on the battery and we can read it. Included in the package you also get a charging cable and a programming USB to serial interface, which connects via this flex cable to the board inside the bracelet. With the proper firmware, with a bootloader in there, you are going to be able to do over-the-air flashing, and I'm not sure that's included in the demo image it ships with, but it should be easy to add that once you start developing on the platform. The default firmware image it ships with appears to be somewhat simple. It turns on, does some checks with the RTC, then scans the Wi-Fi for available networks, and then shows the clock and battery voltage. There's also a screen where it shows the IMU values on each axis, and I must say this small IPS display looks really nice. It's an excellent choice for something like this, and even in my bright lights which I have around the bench, it's still nicely readable. The included programming cable is basically a serial to USB interface based on the CP2104, but they designed this specifically to also include these two switches to control reset and boot signals on the ESP32. The serial interface power as well as the reset and boot signals connect to the ESP32 via this slim 0.3mm pitch FPC cable, which is a neat solution, but like I said, you shouldn't need to use this more than once to flash a bootloader, and then everything can be handled over the air. But if you want to wire that programmer, you will need to open this module, and there are no screws, just plastic clips, and the best way to do it is to start from the side that has the touch button. And now that we are inside the unit, let's pop this under the microscope to get a better look at the circuit and identify some of the chips they used in here. We spot the PCF 8563 real-time clock IC and its required crystal oscillator. There are a couple of spring contacts for the battery terminals which are integrated in the plastic case. This is the TTP223, the circuit that manages touch detection. We have some power related chips in here, battery charging, probably a voltage regulator for 3.3 volts. The ESP32 Pico D4 is easy to spot and is the biggest chip in here. This is its associated ceramic antenna. This is our IMU chip, and because we have the marking MP92, this means it's the MPU 9250 from InvenSense. But apparently this means I have an older revision of the hardware, because newer ones are using the LSM9DS1 IMU from STMicro. I guess that's a cheaper part which does the same thing, and I'm not sure if that's the only change they did to those boards. The battery has no markings to tell the capacity, but I like the fact that it has its own little protection board in there, so it's pretty safe. This is a standard battery used in a lot of devices, and if you do a search for this part number on AliExpress, you'll find it from a variety of sellers, and usually they're around 80 to 90 milliamp hours, but of course this can vary depending on the manufacturer. On the other side we have the RTC backup battery, the display module, an LED, and the touch point spring contact to bring it up to the front panel. Overall, this is quite an interesting package, especially for the price, and you can imagine a whole range of projects you can build on this. I can think of motion tracking projects to detect when a user has been inactive for too long. I can think of smart home type projects where you would use the bracelet to detect the user presence or as a remote control for various stuff, or you can also expand on this by adding an accurate temperature sensor and do some temperature monitoring for the user, and all of this while functioning as a day-to-day watch. It's certainly not perfect quality, but you shouldn't expect that from this kind of product. It's a development platform after all. I'm pretty sure it's not completely waterproof, given the snap fit of the enclosure. There is no O-ring in there, but would probably do fine with some rain. Also, the battery life might not be great on this. It can depend, but the ESP32 is not particularly low power, and so if you turn on Wi-Fi, that's going to hurt battery life a lot. The bracelet rubber is not as soft and nice as I have on my Xiaomi fitness bracelet, but still it does the job, and if you don't have high expectations, you should be happy with this. I just thought this gadget would be pretty interesting to give it a video of its own instead of just a 2-minute view in a mailbag. Let me know in the comments below if you agree with me or why you disagree. If you have some interesting project ideas that can be built on a platform like this, share them below. I'm already thinking about doing a project with this bracelet. If you'd like to sponsor this channel, you can do so on Patreon with as little as $1 per month. And you will also get some benefits like early access to content and exclusive access to updates on the projects I'm working on. Thank you for watching, and I will see you next time with a new video.